chapter 11 is about nuclear and particle physics. Okay, this is the last chapter for this semester lah. And then in this chapter, actually, you can divide into 3 parts. Okay? And these 3 parts, you can treat it separately. Okay, kamu boleh anggap dia benda berbeza lah. Okay? So basically, it is consists of 3 different topics. And then today we focus on the first one, which is about the nuclear. Yeah, I think this one, maybe you already have the basics in chemistry. And in this topic, we will learn about mass defect and then binding energy. So this is the 2 things that you guys will learn today. So before we go further, maybe I can reintroduce this symbol. Okay, so this symbol, I think you guys dah biasa guna kot. Okay, the A here represent the mass number, also known as numbers of proton and neutrons in atom. Okay, kalau yang Z is basically atomic numbers of proton in atom. Okay, kalau yang A tu kedua-dua lah, atau sometimes kita panggil nuclear number. Okay, kalau yang X ni is the symbol. Okay, kalau physics symbol tu maybe kamu boleh letak X if you are not sure what is the symbol. So this is an example. Okay, we have carbon 12, okay, and then 6. Okay, so if you following this one, actually the A is equals to 12, and then Z is equals to 6. Okay. Numbers of neutron is basically A minus Z, which is equals to 12 minus 6, and then equal to 6. So here you can see this one is the atom. Okay, this is the nucleus. So we are talking about this one lah, nucleus. Now inside this nucleus we have 6 proton, 1, 2, 3, 4, 5, 6, and then we have 6 neutron, 1, 2, 3, 4, 5, 6. Okay. Normally in our syllabus we represent P dengan N kot. Kalau kamu tengok nota kita biasa kita letak P dengan N. Proton is P, neutron is N. And then I just want to focus on this one, which is about the nucleus size. Okay, so far any question?
No, sir.
Okay, so this is the first formula that you might use in this chapter, which is N equals to A minus Z. So when they give you a symbol like this, okay, or like this, then you should be able to determine proton number and neutron number. Those are the 2 important things, A dengan N. Okay, so if you want to talk about mass defect, I try to make this one as simple as possible. Okay, contoh, let's say if you have a 3 piece of Lego, ini Lego lah, and let's say you have each Lego weigh 10 gram. Okay? Kalau kamu ada 10 gram and then you add up all this weight, supposedly kamu dapat berapa?
30
gram, right? So this is 30 gram. Okay, this is what it should be lah. And then, but then actually, in case of nucleus, okay, now you add up all the protons and neutrons bila dia dah together. Okay, kamu bayangkan Lego ni dia dah bersambung, okay. And then bila dia dah bind like this, and then when you weigh it up, maybe kamu hanya dapat 28 gram. Okay, so basically you have a missing of 2 gram. Okay, the missing of 2 gram tu sebenarnya adalah delta M. So delta M is actually each one of these, if you add up how it should be lah, contohnya in this case 30 minus 28, you get 2 gram. This is the mass defect. This is what we call mass defect delta M. Faham ke tidak konsep itu? Okay, contohnya kamu katakanlah kamu ada proton dengan neutron, yang katakan 2 proton 1 neutron. So basically kalau kamu add up, kamu sepatutnya dapat nilai 2 proton 1 neutron lah. But then bila kira, bila kamu timbang, kamu dapat kurang sedikit. That kurang sedikit is what we call delta M. In you guys opinion, mana pergi mass? I mean, mass tu hilang ke mana? Kamu rasa lah. Any idea?
Dia jadi energy.
Yes.
Binding energy.
Dia dekat pada binding energy. Very good. So actually kalau kamu tengok definition Mass defect is basically mass difference between total mass of constituent nucleus, maksudnya setiap satu seketol-seketol lah, and the mass of the nucleus. Perbezaan antara setiap satu proton dengan neutron tu dengan mass of nucleus. Mass of nucleus bila dia dah berlekat tadi. Contohnya kalau macam tadi lukisan saya, kalau saya lukis balik let's say if we have two proton and a neutron. Okay, so kalau kita proton dengan neutron ni, benda ni kita panggil sebagai mass of nucleus. Okay. So the mass of nucleus is basically that one lah. Okay. Bila kamu tambah yang dalam ni, kalau example saya ni 1 mn tambah dengan 2 mp, dan minus dengan bila kita timbang, itu adalah mass of nucleus. Okay. Then that mass defect actually telah ditukar pada binding energy. So you can see over here dekat nucleus kita we have 2 proton. Dan proton ni as you guys know dia adalah positive charge lah. So if you have 2 positive charge, if you want to put it side by side, they will create repulsive force. Okay, so there's need another force that will bind this nucleus together. That energy is basically comes from the mass defect. As you guys know, energy is conserved. You cannot simply create energy. It need to be transferred ataupun transform from one another. In this case, dia transform kepada mass. Okay, then that mass, if you want to change to energy, we use this formula. This one is from Einstein relativity formula, which is E equals to mc squared. Okay, so mass multiplied with speed of light square, we will get the energy. So binding energy by definition is energy required to separate completely all the nucleons in nucleus. So nucleons tu tadi adalah proton dengan neutron daripada nucleus dia. Okay, faham ke tidak?
Faham, sir.
Okay, so delta M ni, actually you have mass defect ni, you can calculate into units. Ada 2 unit kamu boleh kira. Okay, saya pergi balik kat sini So normally in the question, they will give you mass of nucleus. Mass of nucleus ni diberilah value. Sometimes they might give you in kilogram. Okay, sometimes they might give you in U. U is basically atomic mass unit. It's a constant, it's a unit. Okay. If they give you in U, basically you have to solve everything in the same unit lah. U. So you use U juga kat sini. Oops. Dan MP pun ada kilogram and U. Okay. The values for MP dengan MN are given inside the formula list of constant values. You can check lah. And they give you 2 values for this one, kilogram and U. So you can choose based on the information that you have for mass of nucleus. And the final answer obviously will follows units. If you use everything in kilogram, then you have everything in kilogram. Okay. If your mass is in kilogram, okay, if your mass in kilogram, okay, you have to multiply with 3 times 10 to the power of 8. This is the SI unit for C. Then you have to square lah. Get the square. So we basically mass in SI unit. C you have to use SI unit MS minus 1, so that your final answer you will have in joule, which is SI unit as well. Okay. Let's say if you calculate M2 using U, okay, now you have to multiply with 931.5 MeV over C squared. So the whole thing over here is basically equal to C squared. Sorry, the whole thing over here, if you multiply with C squared, dia jadi ni lah. Final answer you get MeV. Okay, secara ringkasnya, this one, if you have U, you just have to multiply with 931.5 then you should get final answer of MeV. It's as simple as that. Okay, you don't have to take square. Tak perlu ada square. Okay, clear ke tidak? Ni.
Sir, ulang balik yang you.
Okay, kalau let's say tadi delta M tu macam saya cakap lah, when you try to calculate delta M, you have to use the information that you have from mass of nucleus. If they give you in U, okay, you can straight away use Mn dalam U, Mp pun dalam U, so that your delta M pun you will get U as well. Okay. Obviously, if they give you M nucleus ni dalam U, you can convert to kg, boleh convert if you want. Dan biasanya kita tak, dia biar je dalam U, kita kira data M tu, kita dapat dalam U juga. So, bila dia dapat dalam U, data M ni kan, you just have to multiply with this number. Dia darab 931.5 terus, straight away. Yang C square tu nanti dia cancel out. Jadi unit dia adalah MeV, dia sebenarnya adalah 931.5 over C square. Darab dengan C square tadi kan, so rumus ni memang C square, so dia cancel out yang C square ni. So you left with the unit of MeV. Untuk kau dapat unit dia MeV. So cara ringkasnya, the values of delta M is in U, you just have to multiply with 931.5. Senang je. Okay. Yeah.
Okay, sir.
Okay. Now the next
Okay.
one, another quantity is binding energy per nucleon. Okay. This value will determine whether the nucleon is stable or not. Nucleus stable or not. Okay. So this one is basically EB over A. So the formula just now, yeah, that delta MC square tu dia jadi delta MC square divided by A. A is basically numbers of nucleons. If you guys got confused, A ni kalau kita pergi atas balik kan. Jadi, okay. A is this number yang beratas tu. A tu. Mass number, numbers of proton dengan neutron ataupun numbers of nucleon. Okay, so basically, the bigger this value means that dia lagi stable. Okay. Now we have another graph. Graph ni ditunjukkan as this binding energy per nucleon. This is basically BE over A lah. Against numbers of nucleon A. Dan ini dia ada kat bawah ni A. Okay. So this one is the maximum values of EB over A. Ini paling tinggi lah compare with others. So this is the region where it has the greatest stability. So kalau it's not in that region, like this region and this region, it decays, it will decay towards the more stable. Dekat tengah tu lah. Towards here. Yang if you notice, yang paling tinggi sini, dekat sini adalah nickel. Okay. And ada ferrum and Ge, I'm not sure what it is. Okay, ada soalan tak?
Tak ada, sir.
Okay. There's no question. So basically, itu adalah teori untuk chapter ni. Okay, saya simpulkan sedikit. I'm just waiting for the screen to change. Okay. So again, the first formula that is given inside the formula sheet is this one. A is equals to Z plus N. Okay. A is the nucleon number, Z is the proton number, N is the neutron number. So basically kalau nak cari N, you just have to A minus Z. And then the mass defect formula, delta M. Okay. Normally, when you try to calculate, you just use the unit following the mass of nucleus. Okay. Kalau diberi dalam U, kita buat semua dalam U. Kalau diberi dalam kilogram, everything is in kilogram. Okay, TB is basically binding energy. Okay, this one you have to be careful a little bit. Kalau you use kilogram as a unit, you just have to multiply with C square. Okay. If you use U, just have to multiply with 931.5. Obviously, the final answer will have a different unit lah. Kalau yang SI unit tu, you get joule. Kalau yang bawah tu, you get mega electron volt. Dan mega electron volt tu, saya punya screen lagi. Okay, mega electron volt tu actually you can convert to joule. So mega basically 1 times 10 to the power of 6 electron volt. Just have to multiply with 1.6 times 10 to the power of negative 19. Okay, so these are the constant that are given inside the formula sheet ataupun constant value punya sheet. And you can see here mass of proton they give you in 2 units. Okay, one is in kilogram, another one is in U. You can choose which one you want to use. Okay? Just a reminder, make sure you use all the numbers that are given. You don't have to memorize anything. If they give you 6 number, you have to press 6 number. Dan jangan round off pula. Malas nak berkira kan, letak 4 je jangan. Okay? And similarly with Mn, mass of neutron, they give you in kilogram and in U. You just have to choose lah mana kamu nak pakai. And then lastly, they put here where 1 U is equal to 931.5 mega electron volt over C square. Okay. Yang penting nilai ni je. So as long as kamu multiply with 931.5, you should get the final answer straight away. Okay, ada lagi satu which is this one lah. If you want to convert U to kg, you just have to multiply je. Mass in U tu kan, darab je dengan this number, you should get in kilogram. Okay, if there's no question, cuba kita buat satu soalan, question number 6A. Cuba baca dulu soalan dia. The question state that helium atom is the isotope of helium. Oh, this one is 4.2. Its mass of nucleus is 6.6447 times 10 negative 27. Calculate the mass defect. Okay, so from 4 to HE, what is the value for A dengan, sorry, A kita nak kira lah, A kat situ dia ada, kita nak cari Z dengan N. Apa value Z dengan N daripada situ, kamu boleh nampak. Z dia sama dengan berapa? Numbers of proton.
Z dia dulu.
Z is equals to 2, ambil nombor yang bawah tu kan. And then yang N ni adalah 4 minus 2. Sebab apa? Nombor atas tu tolak nombor bawah. A tolak Z. You get 2. Okay tak ni?
Okay, sir. Okay, sir.
Okay, sir.
Okay, and then they give you 6.6447. That one is mass of nucleus. Okay, now you want to find delta M, which is numbers of proton multiplied with mass of proton plus numbers of neutron multiplied mass of neutron minus mass of nucleus. So your delta M should be equals to, okay, this time do you want to use kilogram ataupun U?
Kilogram.
Kilogram, sebab apa? Mass of nucleus tu dia beri dalam kilogram. So might as well you just use kilogram. Then final answer will be in kilogram as well. These are the constant. Just copy over here. Okay. So kalau dia beri mass of nucleus in kilogram, so you just have to use kilogram. Good, very good. So will be 2 multiplied by mass of proton. Make sure you write down all the numbers. Plus 2 multiplied with 1.674. Mass of nucleus is 6.6. 447 times 10 negative 27. Okay, berapa dapat ni? Cik kira sama-sama. I got here is 4.73. Dapat tak? Cuba tekan sebab this one involve lots of number, so make sure you press it correctly.
Betul, sir.
Okay, betul What is the final unit for this one? Unit dia apa?
kg.
Okay, very good. It will be in kilogram because everything is in kilogram. Okay, that was for question 6A. Okay, moving on to the next one, 6B. Calculate the mass defect of deuterium 2,1 kg. This is deuterium. The mass of deuterium nucleus is 2.01. Okay, we give you this value. Okay, so from this one, you can straight away determine numbers of proton and numbers of neutron. Okay, numbers of proton is how much?
1, sir.
1. Okay, very good. Numbers of neutron?
1.
1 as well lah. 2 minus 1 is equals to 1. Okay, atas tolak bawah, senang je. You get 1. Okay, now you can apply the formula. Data n is equals to z, mass of proton, tambah and mass of neutron minus mass of nucleus. Okay, again, copy this one, yang value ni. Kalau ikut soalan yang this time, you want to use kilogram ke U?
U.
U kan? Sebab apa mass of nucleus tu dia beri dalam U. So might as well you use everything in U. Sorry. In U. Okay, you can convert, alternatively you can convert this one to kilogram lah if you want to. Boleh convert, tak ada masalah. If you use U, so it will be 1 multiply by mass of proton, kalau dalam U adalah 1.007277. Okay, all the numbers are there, plus 1 multiplied by 1.008665 minus mass of nucleus, which is okay. Obviously kalau kamu pakai kilogram atau kilogram, dia punya jawapan tu slightly different lah sebab decimal point dia berbeza. Tapi dua-dua betul. Okay, got here is 1.84 times 10 negative 3. Unit dia apa?
U.
U, okay, very good. Okay, double check the answer. Okay, make sure you get it correctly lah. Okay, boleh tak kita move on to the next question?
Boleh, sir.
Okay, next question is question number 7. This one is 7A. Calculate the energy equivalent in joule of the mass defects 2 times 10 to the power of negative 23. So, walaupun dia ada sebut equivalent tu, basically they just want you to find binding energy. Okay. Dia kata kalau mass defect dia adalah ini, berapakah equivalent energy dia? So, basically binding energy lah. E equals to mc square. Okay, they do give you the value here. Ini value ni apa sebenarnya? 2/10 negatif 31 tu. Simbol apa kita nak represent 2/10 negatif 31?
Mass defect.
Mass defect, right? So it will be delta M. Okay, good. So 2 times 10 negative 31. Okay, this one is in SI unit, kilogram. So you have to multiply with 3 times 10 to the power of 8 SI unit juga lah. And don't forget to take square. Square tu selalu sudah lupa dalam exam. So I got here is 1.8 times 10 negative 14. Okay, unit dia apa? Energy. SI unit.
Joule.
Joule, very good. Okay, senang ya soalan ni. Yang B pula. Given the mass of nucleus is 80.8971 U, calculate the binding energy in unit MeV and joule. and the binding energy per neutron in unit MeV and joule. Okay, this kind of question selalu ditanya dalam exam lah. So dia tak tanya, dia tak suruh cari mass defect, dia straight away suruh cari binding energy. But to find binding energy, you have to calculate delta M first lah. And then biasanya dalam exam dia akan suruh kira dalam salah satu lah, ataupun dia tak cakap. So they say anything, you can use any unit that you want. Okay, back to the question. 81, 35, PR. Okay, Z dengan N. Berapa nilai Z, berapa nilai N? Siapa boleh beritahu? Nilai Z berapa?
35.
35, very good. Nilai N?
46.
Berapa?
46, sir.
Yes, very good. It will be 46, which is 81 minus 35, which is equivalent to 46. Very good. Okay. You can straight away use the formula of E binding, but I suggest for you guys to calculate separately. So delta M, okay, bagi satu setutukan, kata mass nucleus is 80.971. Okay. The unit is in U. So kalau kamu nak kira data M tu kamu pakai apa? U ke kg?
U.
U. Okay, good. Very good. Okay. So again, paste this diagram, this values. So delta M is equals to Z is 35 multiplied with MP 1.672 times 10 negative 27 plus N is 46 multiplied by mass neutron. Okay, saya terpakai kilogram. Terganggu sedikit. So I want to use U because they give you U. So 1.007277. 46 times 1.008665. Mass of nucleus is 80.8971. So this one, I just double check the values to correct. So mass of neutron, okay, mass of proton, I think correct. Okay. So 35 times 0.07277. Okay, so what's the value that you get here? So here is 0.756185. Sama ke tak?
Sama.
Okay. Chapter ni je yang saya suggest kamu tak round off bila kamu tulis. So bila kamu tulis tu, tulislah sebanyak yang boleh. Tapi kalau banyak sangat tak payahlah. Ini macam dalam 6 nombor ni masih okey lagi. Okay, so they want to calculate binding energy in MeV dengan joule. Okay, so basically you have two options now. Okay, you can straight away calculate EB dia, final answer tu tukar je dalam joule, and that is the step that I'm going to use lah. Alternatively, you can convert this one dalam mu kan, you can convert to kilogram. If you want to convert to kilogram, you can multiply with 1.66 times 10 negative 27. Okay, tapi saya kira terus EB dia dalam MEV dulu. So EB binding energy is delta MC square. Delta M is 0.756185. Like I told you before, if they give you delta M in U, you just have to multiply with 931.5. Okay, senang ya, senang. So you get EB equals to 394.197. Saya kira balik. Okay, I got 704.39. Okay, this one correct. 704.39. Unit dia apa? Ya tak, saya cakap kalau pakai U tu dah 931.5, unit dia apa?
MPG.
Yes, mega electron volt. So M2 is mega, EV tu adalah electron volt. Very good. So now I can convert to joule by first. I can take out the mega, so times 10 to the power of 6. Okay, and then I can change EV to joule is 1.6 times 10 negative 19. Okay. Ini macam chapter sebelum ni lah, how to convert EV kepada joule.
Sir, C tu bukan kuasa 2
Apa dia?
C tu bukan kuasa 2
Apa kuasa 2? Sorry, tak dengar.
931/5 tu bukan kuasa dengan 2
Yang ini tak perlu. You don't have to square. Okay, 931.5 ni, kamu tak perlu squarekan dia. Sebab apa? Sebab ini sebenarnya dia adalah per C square. So, kamu darab C square. C square tu berapa? Just darab 931.5 sahaja. Okay? Are you okay?
Sir,
Yeah. So, kalau yang 3 darab 10/8, yes, you have to take square. Kalau 931.5, you don't have to take square. Straight away you get the answer. So I got 1.13 times 10 to the power of negative 10 joule. Okay, that was for B1. Okay, any other question? Ada soalan lain tak? Selain dia tadi. Very good question. Okay, tak ada. Okay, the next question, they want to find the binding energy per nucleon in an EV. Okay, so numbers of nucleon ni berapa? Numbers of nucleon is actually your A kan. A ni dalam sini mana satu A? 81. Very good. Okay, 81. So basically just have to divide EB ni dalam EV ni with A. So EB with A. Kalau dalam MEV dia jadi 704.39 divided by 8. Okay. So your final answer for this one will be in MEV. Kalau kamu nak kira dalam joule, volt, bukan 8 81
ke
81, sorry 81 okay, 81. And then this you will get joule, jangan lupa per, this one per nucleon, this one adalah joule per nucleon. Okay. Untuk yang belah kiri tu agak 704.39 dengan 81. Dapat tak? 88.70. Okay. Dapat good. Dan belah kanan ni 1.13 exponent negative 10 divided by 81, you get 1.395. 1.40 times 10 negative 12 joule per nucleon.